Today we are going to solve some of the CSIR question which is asked in 2018. So we are going to solve about this question first. So among the four compounds are given here: SaCl4, POCl3, NF3, and trans SnCl2 pyridine. Here Py means pyridine, which shows dipole moment. So here we have four molecules: SaCl4, POCl3, NF3, and then SnCl4 Py twice in the trans geometry. Okay, so we know that this SaCl4 comes under the tetrahedral shape. So octahedral compounds and tetrahedral compounds, they shows zero dipole moment. So now in all the options they have given SaCl4, but here they have not given SaCl4. By elimination method we can eliminate this option. So now next we know that NF3 shows dipole moment, where we have NH3 and NF3. So NF3 shows more dipole moment compared to NH3. That means NF3 shows dipole moment. So and here we can remove this option also, because here they have given NF3. So now we need to see about the POCl3 here. So first we have POCl3 here. We just calculate the hybridization of POCl3. So phosphorus is the fifth group, 1 2 3 4 5. So 3 chlorines and this one. So phosphorus is the in tetrahedral shape. If we see the actual structure, it looks like this. This is the structure. So when we pass a plane like this, so it's not like here we can see the oxygen is there. Oxygen electronegativity is greater than phosphorus, and this POCl3 shows dipole moment because oxygen is there, that is more electronegativity compared to phosphorus. So because of that reason this shows dipole moment. And so phosphorus is showing dipole moment, so we can neglect this answer also, and finally we left this answer. That is, in case of SnCl4 we have in the trans fashion. So always trans fashion molecules are shows no dipole moment. So this is the actual structure, it looks like this. Okay, so this shows zero dipole moment. So answer we left here is this one. Okay, SaCl4 and trans SnCl4 Py twice this is. So these two will not show any dipole moment. POCl3 shows dipole moment. And then we have this question. Consider the compounds PF5, SBF5, PH3, and SBH3. The strongest acid and strongest bases. See, we know that superacid concept. We know that superacid concept. When we have HF plus SBF5, we will get a superacid here, and it's very easy to predict the answer here. Strongest acid will be SBF5, and strongest base we need to identify. So strongest base will be among these two. Okay, not here. So now we have a phosphorus, like this is a 3s2 3p3, and antimony, nitrogen, phosphorus, arsenic, antimony, bismuth. So this is 3s, 4s, 5s. This will be 5s2 5p3, and hydrogen is here 1s1. And now so there is a orbital overlapping, there is orbital size differences. So p orbital, this p orbital will be bigger in size, and 1s orbital will be this much small size, whereas 5p orbital, even though more bigger, and this will be hydrogen will be like this. So where proper overlapping we can see, even though in the both the cases we can see less overlapping only, but here we can see proper overlapping. So the more basic will be PH3, whereas when we have SBH3, here the proper overlapping we cannot see because orbital sizes. So because of that reason this will be least basic. And acidity wise also we can talk about this, like we have phosphorus and fluorine. Like this will be, phosphorus will be 3s2 3p3, and this will be 2s2 2p5, and this is Sb, and this will be F. This is 2s2 2p5, and this is 5s2 5p3. So here also we can say here proper overlapping is not there, because of that it's acidic in nature. Okay, so SbF5, we know that is strongest acid, so the answer will be strongest acid will be SbF5, and the strongest base will be pH3. Answer will be B. And then here we have, this is so identify the correct statement for H3B CO. If you see the structure of this one, it looks like this. Okay, so here we can do this answer on the basis of elimination method. Okay, if you see the bond angle of BH, this will be equals to close to 113. So sp2 means it has to be 120, and sp3 means it is like 109, but this is in between, so we can remove this option. Okay, and next we'll go for here VCO value is more than compared to free CO. It's true, because so when we have metal, I'm taking CO6 and metal CO6 positive charge, metal CO6 negative charge. Among these three, which one will be having more CO stretching frequency? So A, B, C. So B will be having more CO stretching frequency, then A, then C, because here less electron density is there on the metal. Because of that, there will be no back bonding with CO, so that the CO triple bond will be as such. So higher frequency will increases for this one. And here there is a more electron density on the metal, so it has to donate electrons to the CO to the back bonding, so this will decreases, and this will be in the medium. So one more thing here we have, when it binds to the BH3 or any Lewis acid. So what about the CO stretching frequency? So in this case, if you imagine this is a D comes here, so D will be having more CO stretching frequency, then B, then A, then C, because itself it's a Lewis acid, so it cannot give any electrons to the metal. Even though here it is electron deficient, it can involve little bit in a back bonding, but in this case it cannot involve in the back bonding. So its CO new CO value, frequency of CO is more than the pre-CO. This is correct. So now we can remove option A. So here we can remove option, this can remove, and we can remove this also. So only left option is B. Next, so so consider the species. We have NO, I2 minus, Cu plus 2, vanadium 2 plus, the number of paramagnetic species among them, and the inactive IR species, sorry, inactive EPR species. So here they have given NO, I2 minus, copper plus 2, vanadium plus 2. So here we need to identify number of paramagnetic and EPR inactive. It's nothing but number of EPR active and number of EPR inactive, because paramagnetic means that is EPR active, right? So when we have a NO in the structure, we'll show one odd electron here. NO is having total 11 electrons, so one odd electron is there, that means NO is paramagnetic. Okay, this is one. Now we'll go for copper 2 plus. Copper is 4s1 3d10, copper plus 2 is 4s0 3d9. So this is also EPR active and paramagnetic in nature, and vanadium 2 plus. So this will be oxidation state of vanadium plus 4, right? X minus 2 plus 2, x equals to plus 2 plus 2, 4, vanadium plus 4, scandium, titanium, vanadium. So this is 4s2 3d3. So vanadium plus 4 is d1. So this is also paramagnetic. Now we'll go for I2 and I2 minus. So I2 means like ns2 np5, right? 5 electrons are there, sorry 7 electrons are there total. So here 14 electrons are there and here 15 electrons are there, right? So now we can pair up in the MOT diagram, like 14 electrons, though it's like comes like we can okay, 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So it cannot be a paramagnetic, okay, because we can take it as a ns, this is also ns, this will be np. So I2 cannot be paramagnetic, so this is diamagnetic, okay, and I2 minus will be paramagnetic because 15 electrons are there, right? So how many total we have here now? Total number of paramagnetic species are 1 2 3 4, and E pair inactive is only one, that is I2. So the answer is this one. Just a minute. So now the chelate rings made by a macrocyclic ligand of vitamin B12. So if you want to answer this question, you have to know the structure of vitamin B12. So cobalt is the central metal atom here. Vitamin B12 is an organometallic compound. That means there is a bond between a metal and carbon. 4 pyrrole rings will be there. Among 4, 3 pyrrole rings are binded with the methane bridge. Okay, so one will be direct pyrrole bond. And here we have alkyl group, and here we have a histidine group. So this is the general, like I am not drawing everything properly. This is the structure of vitamin B12. So now they have asked that the chelate rings here. Okay, so chelate ring means chelate ring made by macrocyclic ligand with vitamin B12. Just take this one as a 1 2 3 4 sorry 1 2 sorry 3 4 5 6. Here we can see one 6-member ring. This is one 6-member ring. Okay, similarly we can count with this also 1 2 3 4 5 6. So here also another 6-member ring. Now we'll go this way, 1 2 3 4 5 6. So this is third 6-member ring. And here see 1 2 3 4 5. Okay, only one 5-member ring. Okay, so here we can see 3 6-member ring is forming here and one 5-member ring is forming. And if you see in options, they have given so one 5-member and 3 6-member, this is correct. 2 5-member, it's wrong. 3 5-member, wrong. 4 6-member, also wrong. So correct answer is first. It cannot be 2. You can count from this side also, 1 2 3, 4, 5, both are same only. Okay. Next we have a magnesium EDTA complex. The number of nitrogen donor and oxygen donor centers are respectively. So first we draw the EDTA structure. CH2, COO minus, CH2, COO minus, COO minus, COO minus, and here we have a magnesium, so this forms a bond like this. So how many oxygen atoms are there? 4. 1, 2, 3, 4. How many nitrogen atoms? 1, 2. So answer will be 1, 4. The correct set of electron configuration, this question we are seeing, the correct set of electron configuration for metal in our octahedral coordination geometry for strong joint distortion. So here we have T2G6 Eg1, T2G3 Eg1, T2G6 Eg3. Just remember, if 4 conditions are there, if T2G is symmetric and Eg symmetric, there is no distortion. If T2G unsymmetric, Eg symmetric, this will be slight distortion. If T2G symmetric and Eg unsymmetric, there will be strong. Then T2G unsymmetric and Eg unsymmetric, even more strong. Okay. So here this configuration looks like this. 1, 2, 3, 4, 5, 6, 1 electron here. 1, 2, 3, 4 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are talking about first option. In the first option, here Eg is unsymmetric, so this shows jointal distortion, and this also Eg is unsymmetric, and this also shows jointal distortion, this also shows jointal distortion, because in all the cases Eg is unsymmetric. So in the first option itself, our answer is there. And here we have a T2G3. So T2G3 is symmetrically filled, so this will not show jointal distortion. And in this case, T2G3 Eg2, so this is also symmetric, and T2G6 Eg2, this is also symmetric, and this is not symmetric. Only this T2G6 Eg3 shows jointal distortion, but these two will not show. And in this case, this will not shows, only this is shows and this is shows. So in this option only all three show jointal distortion. And he has asked strong jointal distortion. Strong jointal distortion means there should be a vacant orbital, unsymmetry in the Eg orbitals, because in case of Eg, there we have a dx square minus y square and dz square, they are directly along the axis. So because of that reason, they will if they are unsymmetry, they will be having a more jointal distortion. Whereas in case of T2G, those orbitals are in between axis, so they will not be showing that strong distortions. And here are the next question. I did not write the options. The correct order of accepting ability of phosphorus ligand. So they have given 4 ligands. PME3, PPH3, POPH3, PF3. So accepting ability means we can say pi acceptor. Indirectly is asking about pi accepting capacity. So pi accepting capacity is catered for PF3, POPH3, then PPH3, at last PME3. So this is the answer. So I did not write the options, just if you have question paper you can see this answer. Okay, so next we have a meridional M PR3 thrice Cl3. This is the complex it has given, and we have a 31P 1H NMR. And in the question he has mentioned that I of metal is 0. Okay, so the structure of meridional looks like this. Facial means 1 2 3, meridional means 1 2 6. This, just remember these 2 points. So 1 2 3 means we start counting from here, 1 2 3 4 5 6. Now meridional means 1 2 6, 1 2 6. We will keep a PR3 PR3 PR3, and here it will be chlorine chlorine chlorine. Wait, I have a doubt about this. So here we have 31P and 1H. So we know that here this phosphorus will give a singlet. This PR3, this is facial. PR3. This is meridional. This is facial. So meridional means 2 3 4, 2 1 2 3 4. And this one is like this. So all phosphoruses are here equal. So for that we will get a singlet. So now in the question they have mentioned that the spin of metal is 0, so there is no coupling with metal. And for the they have asked that 1H, and they did not mention that what is the R group here. So we are not sure about the what is R group here. So we will get only one line here, I think this one. So here in this case we will get only one line, that is because of the all phosphorus are equalite. So there is no metal, and here alkyl group they did not mention. So I am expecting the answer is only 1, because alkyl group is not mentioned. If they have mentioned R equals some CH3, then we can further goes, we can say that 4 lines or 8 lines like that. But since R group is not mentioned, most probably this could be the answer. So this is about this. I have taken only a few questions, so I will make another video 2 3 more. Thank you.